You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. First of all, we'll implement the lab, then I'll show you how to implement the access list. Okay. So let's go to packet tracer. Here I'm taking 2621 XM router. Two switches, 10 devices. So here we have devices like laptop, server, PC, and all, right? Take the cable. Control and straight through. F0 and F01, 0, 0, 4. F0 and F010. Since there are no any other VLANs, we don't need to bother about the ports of switch. Okay, you can connect to any key. Next, we need to connect the router with the switch. So, from switch side, I am selecting fast Ethernet 0/24. In the router, F00. Likewise, in the other switch, F0/24 and router side F00. It's better if I will choose F01 here to avoid confusions. So, go to select. To change the cable, you can simply click on this red icon. So the cable will be removed and again go there and select F01. So now you can see the difference F01 and 00. So in between you can see we can connect F01 and F00 here. So from router to router I am taking a crossover cable F01 and this side F00. Now just turn on the router interfaces and assign IP addresses. Okay. So let's assign IP. First label it. .2.2.2.1/30. This side 2.2.2.2/30 and this side 192.168.10.1/24. This side 192.168.20.1/24. So now you know all these PCs are going to come under 192.168.10.network and the PCs in the right side are going to be in 192.168.20.network. So let's assign the IP addresses 192.168.10.1. So go to PC. This 10.1 is going to be the gateway for all these three PCs, right? Three devices. Go to IP config, desktop and IP config. the last digit. 192.168.10.25. Okay. So /24. So subnet mask I have given, and then again 192.168.10.1 is the default gateway. Okay. So see. Likewise for server desktop IP config, paste default gateway, IP address 10.50, subnet mask. Go to the other PC and you can find the IP address 10.1 again here as a default gateway. IP is 10.75. Let me give it 10.75, and okay, you can give any IP address, right? 10.1 to 10.2 to 10.254. Up to that you can assign. This side it should be 20.1. So server desktop IP config 20.1. So 20.100. Let me give 20.100. Second one. 20.1 is the default gateway. IP 20.150. Then the third one I'm giving 20.200. Okay. So see. We copy the 10.1. Interface F00 is 10.1, right? Go to config F00, turn on and assign the IP. Okay, and subnet mask. So now you can use the graphical user interface for your IP assignments and all, right? Because now your main purpose is learning about the access list, the topic, like when you learn OSPF or access list or DHCP. At that time, don't bother about assigning IP address via GUI. Okay, because from the basics you must know how to assign IP address via using the commands. Okay, at that practice more on commands. But now your main focus is on particular topic. So for the IP assignments and all, you don't need to bother about much on the command side. Okay. So F00, you can assign 10.1 and turn on the interface. F01, you can see it's 2.2.2.1, right? So F01, turn on, and 2.2.2.1. Subnet mask wise, you can see it's /30. So we can specify 255.255.255.4, which means you can go for 240. Remain, this is 24 means this is the subnet mask. Balance 6 bits are there. So 4 bits means you can write 240. 5 bits means 248. 6 bits means 252. Okay. So this is how we will calculate the subnet mask. And then you have turned on, copy this to 1, post it, go to the other router, config F00 interface, turn on, and type 2.2.2.2, subnet mask, you can edit it as 255.255.255.252. Okay, and F01 you can see it's in the 192.168.20.1, right? So copy, go to the router, turn on, and type 192.168.20.1. You can copy paste. Default subnet mask has been given. Okay. So now you can see our interfaces are up. Here is amber orange color. You can fast forward it to make it green 50. Since there are no route protocol, as you know, we can ping from this PC, which means this LAN, up to the 10.1 and 2.2.2.1 only. You can't reach the other side, right? If you want, we can check. Go to command prompt and try to ping 2.2.2.2. Destination will be unreachable, right? Because this router A doesn't know how to go reach the other router. So again, up the row and try to ping 2.1, 2.2.2.1. This home router's F01 interface, right? So you can see it's pinging. Why? This is the router's interface, known interface. Okay. Even if there's a loopback for this router, you can ping that loopback as well. So now, in order to ping from this LAN to other LAN, what you need to configure is route protocol, right? So we have already configured OSPF. So if you want, I can just simply write it. So router OSPF1 and network. You can give 192.168.10. And the wildcard mask 0.0.0.255. Area 0. So this is how you can specify the OSPF. You know that already. We have done this in the last lab. So in another way, since we already have configured the IP addresses, right? So we can simply configure OSPF by going inside the interface. Interface FA00 0/0 IP OSPF1 area 0. Likewise, interface FA0/1 again IP OSPF1 area 0. That's all. So since the both routers are having F00 and F01 ports, you can copy the same command and paste it on both routers, right? Copy. Go inside the router. Select tool, pick the select tool, and go inside the router. CLI. Here. And control S. You are in the privilege mode now. Even if you press exit again, you will be in user mode. Okay. So now enter the user mode. Enable EN. Enter privilege mode. Here you can type config T to enter the config mode. Now only you need to paste the commands. Okay. Paste it. Control Z WR to save configuration. Write command, right? Similarly, go to router 2, CLI. Simply, if you want to read the config mode, now you are in config if mode, which means interface mode. You can press only EX command, which means exit. So you are in the config mode. Now you can paste the command. Enter. Again, C. Again, exit. Now in privilege mode, type WR. Okay. So show IP route OSPF. Okay. Since it takes a bit of time to converge, we just fast forward it. Go inside the router. Now you can see it's from load into full state interface. So OSPF neighborship has been formed. So enter. Again show IP route OSPF. Now you can see the OSPF has been configured. Okay, in this route also you can check the OSPF. Show IP route. You can see OSPF has been configured. Show IP protocols command to verify which routing protocol has been configured. So show IP protocols. You can see OSPF has been configured. Routing protocol is OSPF 1, right? So now let's try to ping from LAN 1 to LAN 2. Okay. So from this laptop, the IP address of this server is 192.168.20.200. So go to the laptop, ping space 192.168.20.200. Enter. Okay. You can see it. You can see the ping is successful. Okay. First packet got lost because of the ARP address resolution protocol. Now let's close this. So here's what we are going to take an action in order to make our learning quick. Okay. We are going to learn standard access list, extended access list, and based upon certain conditions, we need to implement several access lists and practice. Then only our understanding towards the access list will increase, right? So again and again, if you wanted to implement this, then your time is going to be wasted. So the better way is just copy it, select it, and control and drag and drop. Okay. So again, click on the highlighted area and drag. Okay. So likewise, you need to make several copies, around 4 or 5 is better. So just copy paste. From this labs, you are going to practice our other access list by changing the conditions, how the access list changes affect the output and all. We can check upon these labs, okay, without preparing for the lab again and again. We just did it once and we are copy pasting it. Okay. Next, I will show you how to write the access list. Okay. So here our condition is going to be, you can check this image, and the fourth step, create standard access list to block traffic from 10.10 to server 20.20, which means from this LAN 1 to LAN 2. We're going to block the 10.10 traffic reaching the 20.20. Okay. So here to write the standard access list, you just wanted to remember access list 1 permit any. Okay. So from this access list, you can simply implement other access list as you wish. Okay. As per our need, we need to implement the other access list by using this one. So copy it. So I just pasted my access list. So here in access list portion, you can have access list. Okay, so it's not going to change. In the 1, you can add numbers from 1 to 99 or else of 1300 to 1999. Okay, and in the permit position, you will have it whether to permit or deny. Okay. And in the any position, you are having your IP address, IP and wildcard mask. Remember, I told you when we implement the OSPF, for OSPF and access list, we are using only the wildcard mask, not the subnet mask. Okay. So this is what you are going to remember when you implement other access lists. Okay. So simply access list 1 permit any. So now our main focus is we are having R1 router and R2 router, right? So this is how it looks like. So 10 dot network, 20 dot network. Okay. So we need to block this 10 dot network traffic reaching out 20 dot network. Okay. So in standard access list, you already knew you can't predict about the destination. Okay. You can't filter via the destination state, so that we are implementing it closer to the destination. So here 20 dot is our destination. So we are going to implement the access list in the router 2 and apply it in this interface. Okay. Let's say this interface is F0/1. We are going to apply this access list. We are going to write several list of statements and apply it here. Okay. Whether to permit or deny has been checked. So here our statement is 10 dot network must be denied, which means blocked. Okay. All other remaining traffic must be permitted. So in any access list, as I told, in the end there will be an implicit deny statement which blocks each and every traffic, right? So if you didn't specify this access list 1 permit any statement, each and every traffic which passes this router 2 will be blocked, right? So that is the reason we are going to apply this access list 1 permit any statement in the end. Okay. So in front of that, we need to write a statement to block the 10 dot network. So what we are going to do is, again, access list, okay, and the same number. Here we have used 1, so our entire access list must contain the access list number 1, right? And then space. Then here the traffic is having permit statement. Now we are going to deny traffic for 10 dot. So you need to use deny. Okay. Instead of permit, we are using deny. And next one, space any. In the any statement means the any statement ensures any IP address, any wildcard mask. But now we have 10 dot network. So we specify 192.168.10.0 space the wildcard mask of /24. So 0.0.0.255, right? So now any PC in this 10 dot network from 10.1 to 10.254 will be blocked passing this router 2's F01 interface. Okay. So this is the first statement. This is going to be tested against this traffic. If there are any other traffic comes, for example in router 1, if you connect a 50.1 interface, in router 1, if you are connecting 50.1 network, so what happens? The traffic goes up to here and the access lists are being checked in this F01 when it passes the router. Okay, it comes all the way here, it's going to be checked. So 192.168 10 dot has been checked first, whether the traffic is coming from 10 dot or not. So 50.1 is not in 10 dot network, it's not going to be blocked. Okay, so next step, the next statement is access list 1 permit any, which means you can permit any traffic via this interface. So this 50 dot traffic will be permitted. Okay, so these are our first two statements. So we have implemented a standard access list. Once after you implemented the access list, you need to apply it to this interface, okay, via the access group command. So go inside interface FA0/1. Okay, you are inside the interface. Type IP access group 1. The number is used for the access list. Access group 1. Whether it's incoming or outgoing traffic. Here the F01 interface is the outgoing interface for router 2, right? So IP access group 1 out. Okay. So now copy these two commands, access list 1 deny statement and then permit statement for any other IPs and wildcard mark. Copy, or else we'll copy everything to the packet tracer and then we'll be pasting. Okay. Copy only the access list commands now initially. Select 2, go to router 2, config mod, enable config and paste it. Okay. Enter. Okay. Show run. You can see your access list have been mentioned here. Show run. Okay. But in the interfaces there is no any access group command. Okay. So if there is no access group command, let's see what happens. You can ping this server. That's it. Okay. 20.network. We see from PC command prompt. Again I'm typing the previous command, okay, so which is 20.200 192.168 20.200. Enter it. You can see it's being pinged, right, which means 10.network is being allowed for the 20.network. So now I'm going to apply my access list via the access group command. Copy this. Interface F01 IP access group 1 out, which means the outgoing traffic from S01 port is going to be blocked via from the 10.network, right? If it is coming from any other network from router 1, it will be permitted. Okay. So go to router 2, config. Interface F01 IP access group 1 out. Enter it. Exit. Again exit and save. Right. Show run or show access list. You can see the access list, right? Space. You can see the access list. And also access group command has been applied, okay, in the interface F01. So now we can ping from this to LAN 2. Up arrow. So if you check ping, now the packets must be blocked. Okay. Destination unreachable messages appear. Why? The access lists are blocking your traffic. You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us.